So, what do you remember from last year about angles? What's it called when an angle is less than 90? Obtuse. Bigger than 90?
Obtuse.
Okay.
Right angle.
What else did you learn about last year about angles?
Right angle.
Right angles is 90 degrees.
Obtuse 35.
What's the little corner of the angle called? Starts with a V. With a vertex. The vertex of the angle. You remember that?
Can we be right angles?
No, this is stuff you learned last year. What else did you learn last year about angles? Anyway, that's about all I can remember from last year. We got to talk about what are called an angle in standard position. So it has to do with a graph. There's a lot to draw here, but draw it. Draw that picture there. That picture right there. You can't see it?
You really to make us draw this?
Yeah. These papers? No. Shoot.
We all know it's me.
Thank you.
My prize.
One way to, depending on who your teacher was last year, you might have gotten out a protractor. You guys ever used a protractor to measure an angle?
Like in elementary school?
Maybe, I don't know when you would have done it. So we're going to measure angles without a protractor. They're going to be angles in standard position. And we're not going for exact angle measures here. Some of them are going to be approximate. Now going back to what I was talking about earlier, if an angle's bigger than 90 degrees, what do you call it? Obtuse. Okay. So bigger than 90 is obtuse. What if it goes to a straight flat line?
Line.
Well, how many degrees is it?
180.
180. What if you're imagining an angle is increasing to 90 and then it increases to 180 and then goes beyond 180?
That's true.
So that's what we're going to be looking at. Some of these angles are going to be larger than 180 degrees. We're also going to look at negative angles, or angles with a negative angle measure. So as you're writing, I'm just going to explain some of the things on the picture here that you are drawing. When you put an angle on a graph in standard position, you've got to make sure the vertex of the angle is on the origin like I've drawn. You've got to make sure one side of the angle lies on the x-axis pointing to the right. That's called the initial side. Every single time the initial side is on the x-axis pointing to the right. Okay. And then the other side of the angle is called the terminal side. That's the side that's going to be moving around depending on how big the angle is. Okay. And notice these Roman numerals I have written. These are called quadrants. Quadrant 1, 2, 3, and 4. You always go counterclockwise for the quadrants. So depending on what quadrant the terminal side is in, that can help you estimate the measure of the angle. So in quadrant 1, we're dealing with acute angles from 0 to 90 degrees. In quadrant 2, we're dealing with obtuse angles 90 to 180. Okay, but if the terminal side happens to be in quadrant 3, that's an angle measure that's between 180 degrees and 270 degrees. Okay. If the terminal side happens to be here in quadrant 4, then you measure all the way around. It's going to give you something between 270 and 360. Now notice what I've written here. If you start on the initial side and measure counterclockwise, like this blue arrow is pointing, that's going to be a positive angle measure. But if you look at this, what I have written in red here, if you start on the initial side and measure clockwise, that would be a negative angle measure. Okay. So this one angle could be measured two different ways, and it's the exact same angle. Just as an example of what I'm talking about, how would we estimate the measure of this angle? We know it's the terminal sides in quadrant 1, so it's got to be less than 90. What is it? Maybe 70 degrees? Okay. But that's if we're measuring it positive. We could call this positive 70 degrees if we're going counterclockwise. What if we're going clockwise when I start on the initial side and go all the way around to here? So let's do this all together. If I go clockwise down to here, isn't that negative 90? Then that's negative 180. That's negative 270. And how much more? Let's try this one more time. If we're saying this is positive 70 degrees, then isn't there a 20-degree gap right here? So now let's go around the other way, going clockwise. From here to here is negative 90, negative 180, negative 270. And what was the gap we said? 20 degree. So it would be negative 290. This one angle could be measured two different ways and have two different angle measures, but it's the same angle.
Either 70 degrees positive or negative 290 degrees negative. We good? And that can be true of any angle.
You can measure clockwise or counterclockwise and get a positive or a negative angle measure. So what you guys need to do, page 388. I want you to do the problem 1, got it. The problem 1, got it, on page 388. Just got to give your best estimate. Just to have something to have as a reference, you know. Copy the picture down as well. Copy the picture of the angle and give your best shot. 388. The problem 1, got it. While you're at it, because this is kind of simple, do the A practice problem 1 and 2 just underneath it.
This is what I'm getting. The problem 1, got it. Since you're going counterclockwise, isn't that a positive? And again, we're just estimating, so as long as you're pretty close here. But the reason I chose 225 is that's exactly halfway between 180 and 270. And why am I going exactly halfway between them? Yeah, what else on the picture is there? Isn't there a point, negative 2, comma negative 2? Kind of like the slope of the line is cutting right through that quadrant. You know it's right in half. Alright. And this is the A practice problem number 1 right here. Why am I calling this negative? Clockwise angle measure has to be negative. So from here down to here would have been negative 90, negative 180, negative 270. So I know it's beyond negative 270. Okay.
And wasn't there a point on that one too? What was the point on that one? 2, comma 2? So that's cutting it right in half as well, so negative 315 would be the exact measure there. Now, the question 2 here for the A practice, I'm just estimating there about 155 degrees, maybe 160, maybe 150, somewhere in that range. If we have time later on in the unit, we can learn how to use the actual points on the angle. But right now, it's not super important. You feel like I have a handle on this? All you need to know right now is be comfortable between a negative and a positive angle measure. We're comfortable on that? Also, knowing what it means where the terminal side is in a different quadrant. Okay. Go to problem 2, got it. Part A, B, and C. Now you're sketching your own angles. So the problem 2, got it.
let's not take too much time with this. We gotta keep this moving. But and again, you guys don't have Protractor, so I don't expect these to be exact. The terminal side just has to be in the right quadrant.
So the problem 2 got it, part A, B, and C. One thing you gotta be sure of is not just that you have the same picture, but that you have your angle measures drawn in the correct orientation. It's got to be either counterclockwise or clockwise. All right, let's get. Let's get one of you ladies up here. Volunteer for party. I said, let's get a lady up here. For party, come on.
I'll do it.
You can do part B.
All right, I'll do part B.
Want to do part A? All right. Sweet. Let's grab one of those pens up there. What color do you want, Al? Blue? All right. Yep, 85 degrees. Cool. What do you guys think? Positive 85 degrees, and she went counterclockwise, and it should be pretty close to 90 degrees, right? All right, I'll take that. All right, you said part B. What color do you want?
I would like green. Did you say what was the degree again?
Negative, what was it, 300 or something? Negative 320. Negative 320.
Okay, so I'm pretty sure you go around, right?
Yep.
And then so it's 360, so you like 40. So that's a little past half. There, right?
What do you guys think?
A little bit past, it's like 5 degrees past half.
I'm okay with that. I'll take it. And then what about part C? 180 degrees?
Yeah.
Just a straight line, right? But you got to make sure that you've measured positive 180 degrees. You have to show this measurement right here. Okay? All right. Switching gears here. Write that word down, or that phrase, coterminal angles.
We actually already talked about it, but
Yeah, and you see what they want. So, all right, imagination time. If I ask these 3 rows right here to graph 45-degree angle, and then I ask you guys over there to graph negative 315, so you guys are graphing 45, you guys are graphing negative 315. What would your pictures look like? The angles would look the same, except one of you would measure clockwise, the other one would measure. But wouldn't the angles be in the exact same spot?
Yeah.
Those are coterminal angles. That's all they are. Okay. So just have a picture as a reference. This will be an example of a coterminal angle. The picture looks the same, it's just measured differently. Coterminal angles are angles that have the same terminal side, but they're measured differently. Some students think it's kind of weird to have an angle that's bigger than 180 degrees. You guys seem to do okay with it. What's the biggest angle I can draw on that graph?
360. 359.
359. What if I was facing you guys and turned all the way around once and faced you again? How many degrees did I turn?
Actually,
360.
What if the turn is 180?
What if I turned around twice, 2 complete circles, and then faced again? How many degrees did I turn?
Only 180. Only turn 180.
You guys have been snowboarding, right? Or you've seen people snowboarding, or you've seen them doing tricks on the half pipe. What do they call it when they turn twice and land again? A 720. Why is it called a 720?
Go around 720.
Gone around twice, 360 degrees times 2. So you can actually have angles drawn that are bigger than 360 degrees. You guys following? So let me get a new picture here.
Before you finally paused it.
Pop, yeah. So draw a blank graph with a 45-degree angle but no measurements. So just like that. All right, try to follow this. You ready? If I start on the initial side here, you watching? If I started on the initial side and measured counterclockwise but went through the terminal side all the way around like that, how many degrees is that?
405.
So that's a 405-degree angle right there. All right. I know it looks like a 45-degree angle, but I've measured it through the terminal side all the way around the circle once, and then 45 more degrees, so it's a 405-degree angle. But what if I did a different measurement in black? Watch the one in black. What if I just did that angle right there? Then what's that angle? That one's 45 degrees. So don't these two angles have the exact same terminal side in the same spot? What's it called when they have the same terminal side? These would be coterminal then. Now I know I'm using all sorts of different colors that you guys don't have, but check this one out. What if I started on the initial side and went this way?
That'd be negative. Wait, just right there?
I started on the initial side and went clockwise. What angle measure is that?
It's not a coterminal because you didn't go all the way around again.
Didn't I still end in the same spot?
Yes.
Wouldn't that be negative 315?
Yes.
So all three of those are coterminal.
Oh, wow. You have more than one. You're too fair.
Okay, try to follow this one. You ready? We need, what do we need? Purple? Let's do purple. What if I started on the initial side, went around once, went around twice, and then went up like that?
720 plus 45, that's 765.
So there's another coterminal angle. All four of them are coterminal. So the point I'm trying to make is how long could I make this list?
As much as you want.
Just keep going around the circle, right? So with one given angle, there's an infinite number of coterminal angles with it. You just have to keep going around the circle, clockwise or counterclockwise. You following?
Yeah.
Okay, so here's an example. This one's not in your book. But, yes, please. So give me one positive and one negative coterminal angle for 200 degrees. Don't yell it out. Write down on your paper. 200 degrees. And I want a positive and a negative coterminal angle for that. You don't have to draw this, but it might help if you draw it. Take like 20 seconds. If you're finished already, just compare with those around you, see what they have. All right, we got to move this along. I know it's not a ton of time. Sorry. What are some of your positive ones? Not the negative, the positive. 560? Where are we getting that from? Yeah. If you just go to 200 degrees and then go one more circle, do you guys see what happened there? How many degrees is one more circle? So all you really have to do is add 360 onto it. You don't have to draw. You can. It might help to see it on a picture, but with any given angle, you can add 360 degrees and you end up at that same angle again. So that's a coterminal angle. So yeah, 560. Is that the only right answer for a positive? What if I wanted to add 720? Could I have done that?
Yes.
I would have gotten then 920. That could have been. That's just going twice around the circle. But anyway, 560 is probably the most common one. What about a negative? So look at the picture I have. If I started on the initial side and went down this way, that would be negative 160. Or you could have subtracted 360 from the original angle. Give you negative 160. Okay, I can't give you much time on this, but I want you to think about it. What if you have a larger angle, 620, and I still want a positive and a negative? I want a positive and a negative coterminal angle for 620 degrees. So I want an angle that looks just like that one, just measured it differently. Do you guys understand what I'm asking?
Yes.
One positive and one negative?
Just subtract 360. Not like that.
Well, the problem is if you subtract 360, what do you get?
Still the same angle.
It's the same angle, yes, but I want one positive and one negative.
Then add 360.
So the problem we're having is we can't. Where's the negative coterminal angle? What if we just subtracted 360 again? Wouldn't that just be going around in a circle again? So 360 or 260 minus 360?
Negative 1.
So there's your negative one. But we had to subtract 360 twice. What about a positive one? We had a positive one right here, 260. So you don't always just have to add or subtract 360. Sometimes you have to add 360 twice. Sometimes you have to subtract 360. Anyway. You guys with me still? Okay, we got to move on to our last topic. The unit circle. Okay. So, draw. So it's called the unit circle because the radius is 1 and 1's called the unit length. It's pretty useful for a lot of things, but for us in particular, it's really useful to help you find the sine, the cosine, and the tangent, the exact value of the sine, the cosine, and the tangent. So you guys did that on the quiz today where you had to find the sine of 60. Do you remember that question?
Yes.
How'd you do that one?
You get this special thingy.
The special triangle. Even with that, it wasn't that hard. All you had to do was memorize the special triangle, but it's actually even easier with the unit circle. Jared, do you want to hit that door for us? And maybe the light switch too while you're up. Just to do. There you go. Thank you. Oh, I might not have enough copies.
Oh well, I guess we're done here home.
Yeah, you still have it, so I'm going to have to do it without the unit circle.
This one. Oh, I totally could transfer 13 more. Look, I have a picture of what I felt. For that right there.
Okay, first thing we're going to do is fill in the angle measures. You guys, we're only down to 13 minutes or so you got to stay with me. I'm going to move pretty quick. Put your phones down,
I'm filling it out.
and let's fill this out accurately so you don't miss anything. Phone down. So, right here is 0 degrees. The larger gaps are gaps of 30 degrees. The smaller gaps are gaps of 15. So from 0 we go up to 30, and then from 30 to 45, 45 to 60, and then we have a larger gap. That's a gap at 30, so 60 goes to 90. And we have another gap at 30, so 120, 135, 150, 180, bless you, and then 210, 25, 240, and 270, and 300, 315, 330, and 360. Now, the blanks just next to them, we'll talk about this next time, don't worry about those blanks. But the blanks outside the circle, see how they're in parentheses? That means we have to find the coordinate location of each of these points. Some of them are pretty easy, like this point right here. This is a unit circle, yes? What did I tell you the radius was? So if I've started at the middle, I'm going all the way out to the edge of this circle. How far have I gone? And then how far up have I gone? So it's 1, 0. You guys with me still? Now skipping these ones in the middle. What if I start at the origin and go straight up to the top of the circle? That'd be 0, 1. This would be -1, 0. 0, -1. Good. I know I'm going pretty quick. I'm sorry, but I want to get this done before the bell rings. This next part, I don't want you to draw. I'll tell you when I want you to start putting stuff down. So pencils down. I want you to look up here at the screen. It's important to understand where these numbers are coming from. Okay? Does this look familiar? 30, 60, 90 with 1, 2, and a square root of 3. Does that look familiar? We learned about this yes time, yes? Last time? What if I divided that by 2, divided that by 2, and divided that by 2? This is something you guys talked about last year with similar triangles. As long as you multiply or divide every side by the same thing, you get a similar triangle, right?
And the decimal stay the same.
And the degrees stay the same. So doesn't the hypotenuse become 1? But isn't this still the same triangle? Just a different size? Now the reason I did that to the hypotenuse is if I started at this point, came straight down and formed this triangle right here. What's the measure of this angle?
90.
And isn't this 30 degrees? So this is 30 and this one would be, okay. What kind of circle is this? Unit circle. And what's the radius of a unit circle? So don't I have to put a 1 right there? Because isn't this a radius? And the radius of a unit circle is 1. And is this the hypotenuse, yes or no? Is this the hypotenuse, yes or no? This is the hypotenuse? Yes. Okay. So this triangle should be the exact same as this triangle now, right? Because this has a hypotenuse of 1, this has a hypotenuse of 1, and it's a 30, 60, 90. You guys with me?
Yeah.
So then the smaller side should be 1/2. The other side should be the square root of 3 over 2. This triangle matches this triangle, yes?
Yeah.
Now, a point on a graph, isn't that just an x and a y? What does x describe? Left, right, or up and down?
Right.
Left and right. So if I started at the origin and went straight over to here, how far to the right did I go? Square root of 3 over 2. Because isn't that the length of that side? Now what does y describe on a point on a graph? It describes up, down. So if I started and went up, I went up 1/2. Did I not? That's where those numbers come from. They're coming straight off the special triangles. That's why you can use the unit circle as a replacement for the special triangles. So we had 30, 60, 90 triangle, right?
Yeah, I can't call that the two sides. I think that which one's that?
Well, the x has to be the horizontal component, because that, and y has to be the vertical component. Does that make sense?
Yes.
Now, I wish I had time to show you all the rest. I don't. This is what you need to have drawn on your, well, not drawn, but written. You need to have that point right there. Square root of 3 over 2, comma 1/2. I don't have time to show you where the rest of them came from, but you just have to believe me that we could do that to all these other lines, make special triangles and figure them out. But anyway, this one's a square root of 2 over 2, comma square root of 2 over 2.
What's the radical for the 0 degree and 360? Or the
1 comma 0.
no. To the left. It's to the left. No. Okay, go back to C360. The line right to the right.
We haven't done that yet. That's next time. It's radians. Okay, and then this one up here is going to be 1/2, comma square root of 3 over 2. Got to make sure that you have labeled these points exactly like I have. Now the nice thing about a circle is it's symmetric. As long as the origin is at the center, like we have here. All 3 of these points in quadrant 2 are symmetric to these points right here. For example, you see what I'm circling here? What does it have to do with that point there? Don't you go up the same number of units? So shouldn't the y be the same? Because we went up the same number? We're still going up, so it should be a positive y. But x is negative, because didn't we go to the left and then up? So it should be negative 1/2, comma square root of 3 over 2. The x is negative, but the y is positive. Why is the y positive? Because you're still going up. But the x has to be negative because you're going to the left. Now what about this point right here that I'm circling? Negative square root of 2 over 2, comma, positive square root of 2 over 2, right? And then one just beneath it is going to be negative square root of 3 over 2, comma, 1/2. Now, what about this one right here that I'm circling? They're both negative. X is negative because you're going to the left. Y is negative because you're going down. But you have to be careful which one you're reflecting. This point right here is a reflection of this point right here, isn't it? So this point right here is a reflection of this point. So it's going to be negative square root of 3 over 2, comma, negative 1/2. Now I need you guys to look at me for a second. Stop writing, look at me. Part of your homework, just because of lack of time, part of your homework, I want you to fill in the rest of these, okay? You guys following? We don't have time to do that right now. I want you to fill in the rest of those because we got to move on to something real quick. Across the top of your unit circle, you have a little bit of a blank space, right? I want you to write this. Cosine of an angle is equal to x. The sine of an angle is equal to y. And the tangent of an angle is equal to y over x. Now here's the thing. On your quiz today, I had you guys tell me the sine of 60, didn't I? You need to write this down. I just want you to watch for a second. I had you guys tell me what the sine of 60 was. The way that you probably did this was you did the special triangles. 60 degrees was right here, so opposite over hypotenuse was square root of 3 over 2, right? Isn't that how you did this on the quiz? Well, check it out. Using the unit circle, what is the sine equal to on the unit circle? It's equal to y. So go to 60 degrees, which is right here. And what's the y value? Square root of 3 over 2. Okay? You don't have to use special triangles. You just have to remember that cosine is x and the sine is y. Okay?
Oh, yeah, that makes sense.
So had I asked you this on the quiz, or had I asked you this now, what's the cosine of 120? You don't need a special triangle anymore. Go to 120 on your unit circle.
Negative 1/2 over 2.
Negative half over. Negative 3 over.
120 degrees is right here. And is cosine x or y? So the cosine of 120 would be negative 1/2. Just as easy as that. Okay, you guys do have online homework for this? Yeah.
Turn it in. The worksheet. The trick review thingy.